having 5 sense. That is nothing but we can see the things and we can listen the things and we can feel the sense and we can taste and we can what we can call it. These are the 5 organs that human is having the same functionalities that what we are going to do. We are going to implement these 5 basic fundamental things in the machines like listening and speaking. That means we are going to implement these features in the machines like the machine has to listen and it has to respond. That means it has to speak and it has to understand the languages. Here, the human can understand the languages by listening and by using some signs and remembering the things. That means human can store their information in their brain like that. The machines also what it has to do. It has to remember the things and then it has to act according to that particular situation. And similarly, the machines also think in the smart way how the human brain is going to think. Okay, like seeing and moving, all these functionalities that what we are going to implement all these fundamental things in the machines. Here, the very first one is nothing but listening and speaking. Okay, uh, here we can see, for example, here we are going to use Google Translator that is going to working by using AI principle only. Okay, understanding languages. That means the machine has to understand the languages. Means here we have to know some of the basic fundamental things related to natural language processing. Okay, here we are going to understanding the languages. For example, the human that what we are going to use different types of languages. The same way that what we are going to do, we are going to feed our machines in different languages. Okay, that means in our area, for example, in Telangana, we people are going to use Telugu. For example, if we take our India, we are going to use common language Hindi. Okay, like that, that what we are going to here we are going to feed the machine like in different languages. And next one is nothing but remembering the things. Okay, here, however, the human being is going to remembering the things in the similar fashion. We are going to implement the same functionalities to remember the things by the machines. Here, we are going to use hierarchical representations called analogies. Okay. Uh, Next one is thinking. The machines also has to think how the human brain is going to think and act related to the particular task. Here, the machine has to think and it has to respond for the particular tasks. Like that, what we are going to do, similarly seeing for here we can see by using eyes, the machines that does not have any eyes. So that what we are going to do, we are going to use some sensors. Okay, based on the sensors, we are going to sense the thing and then we are going to act. Similarly, moving. Okay, here we can move by using our legs. Similarly, we are going to move the what we can call the machines by using the motors, or that is nothing but a robotic concept that we are going to use. Okay, these are the domains generally that what we are going to consider while going to design any AI machine, or whenever we are going to design any robot. Here we are going to see the major difference between the artificial intelligence and machine learning. Okay, here the artificial intelligence is nothing but it is going to, that means here we are going to make the machines. Okay, that means we are going to feed the machines to do this particular task. Okay, that particular task only that it is going to do. But whereas in machine learning, it is not like that. The machine learning is a subset of the AI. Okay, that is nothing but artificial intelligence. Okay, here the machines are going to learning from by using the data. Okay, again here we can find the machine learning is an application of artificial intelligence that involves algorithms and data that automatically, that means here it is going to analyzing the data, but whereas the artificial intelligence is not going to do this particular task. That means the enhanced version of the artificial intelligence is nothing but machine learning. And the next one here is nothing but here we can find here we can find 3 different types of machine learning algorithms. That is nothing but a supervised learning, unsupervised learning, reinforcement learning. Okay, we will see first what is mean by supervised learning, unsupervised learning, and reinforcement learning. The supervised learning, that what we are going to we are going to labeling the data. The supervised learning is nothing but that means that what we are going to do, here we can predict the output. That means, for example, we are going to give some input and we are going to expecting the output. That output that we know. That means that what we are going to do, we are going to label the data. Okay, in the supervised learning, that what we are going to do, we are going to label the data. But here again in the supervisor, we have two methods are there that are nothing but classification and regression. We will see what is mean by classification and regression. Okay. Here this is supervised for every example in the data. There is always a predefined output. That means in the supervised learning, we know what is mean by what is the input and what is the output. But whereas in the unsupervised, it is not like that. Okay. Here the models that relation between a set of descriptive features and targets. Okay. Two group of problems, that is nothing but classification and regression. Okay, we are going to see classification and regression. Before that, we will see unsupervised learning. In the unsupervised learning, that what we are going to do. The unsupervised learning, here we don't know the what we can call the output. We can't predict the output. Okay. This type of algorithms consist of only input data, and that data also it is not labeled. Okay, for example, if we take in the supervised learning, that what we are going to do, there we can predict the output. But here I will tell one simple example so that we can easily understand what is meant by supervised learning and unsupervised learning. For example, if a baby boy is there, is going to play with his pet dog. Okay, that means the boy is going to know what is meant by dog and the features of that particular dog. For example, if he went to his neighbor's home there, if he find similar kind of animal, means he's going to first he's going to see the features of that particular animal, whether it is having the eyes, nose, and ears and mouth, all these features that he's going to compare that animal with this dog. If it is matching that one, then he's going to know that, oh, this is a dog. Like that, he's going to think, and he is going to assume that it is a dog. Like that, what we are going to do in unsupervised learning, here we don't know the output. That means that what we are going to do, being the previous experience, that we are going to assume that this is the output that we are going to get. Okay, that means there will not be any pre-existing labels, and the human invention is also less in the unsupervised learning. It is mostly used in exploratory analysis. It can automatically identify the structure in data. Here we can find one simple example. It is related to flower. There, what we are going to do, we are going to measure the sepal length and sepal width, petal length and petal width, like that. There, what we are going to do, we are going to find in the particular flower. Here, next one is nothing but a reinforcement algorithm. Reinforcement algorithm here is nothing but it is speakingly, it is a combination of what we can call supervised learning and unsupervised learning. That means in this we can find both labeled data and unlabeled data. That means this model is used in making sequence of decisions. It is a learning by interacting with the environment. That means here we can easily understand that here we can find what we can call labeled data and unlabeled data. Okay, reinforcement is nothing but it's a mixture of the both supervised and unsupervised data is nothing but a reinforcement learning. Okay. Can be said that it is a trial and error method in finding the best outcome based on experience. We can find some of the real-time examples related to the machine learning. That is nothing but we can also predict the what we can call the traffic. For example, if you, here by using machine learning algorithm, here we can estimate how much time to take reach our home, okay, from office to your home. Okay, that is by using nowadays we can find whenever we turn on your GPS. Okay, for example, if you want to move from one location to another location, sometimes we can find some red light in particular some areas, some red dots in that particular area. That means there we can find there is a huge traffic is there. That means there we can find there we can get some time delays like that. Okay, all these things are going to run inside by using ML algorithms only. Okay, next one is the virtual personal assistant. Okay, like we can see here Google Hello. Okay, this is the one. Okay, next one is online transportation. Here also that part is going to here inside we are using the machine learning algorithm. Like that, we can also use this one in the social media services. Okay, in apps like Facebook, that means, for example, if you see in our Facebook that sometimes what we can do, we are going to find some mutual friends. For example, X and Y people are there. Means the X and Y common people, that automatically it is going to filter out and it is going to give suggestions. Better you can add this person. He is a common friend between you, X and Y, like that. That means all these things are going to happen by using this machine learning algorithm only. Next, email spam in the olden days, that what we can see, all the mails are that are going to come into the main primary inbox only. But nowadays we can find some mails directly, it is diverted to spam, and some are coming to our primary mailbox. These are the things that are going to happen by using algorithms only. Like that, we can find several what we can call the examples related to this machine learning algorithms. Here, if you see, this is a simple slide. In the slide, that what I'm going to do here, I'm going to differentiating the supervised learning and unsupervised learning, and how we are going to do the clustering, classification, regression, and dimensionality reduction. Okay. See your supervised learning. Okay, the supervised learning, in the unsupervised learning, that what we are going to do the clustering. Here we can find two different types of data. One is a discrete data, and second one is a continuous data. Okay, for example, we are taking the input data. Here is nothing but a discrete data. Means at the time in the unsupervised, that what we are going to do, we are going to do the clustering mechanism. For example, if you have a group of red and blue, yellow balls are mixed together, by applying the clustering concepts in unsupervised, that what we can do, we can separate red balls, green balls, yellow balls, like that. Okay. That that can be done here by using these clustering concepts. Okay. In the clustering, we are going to use several different types of algorithms that we are going to use clustering. That means in order to cluster the what we can call the red balls, green balls, yellow balls, like that, we are going to use k-mean clustering algorithms and mean shifting clustering algorithm, clustering algorithm. These are some of the clustering algorithms, spectral clustering algorithms. These are the algorithms that we are going to use in the unsupervised to cluster the data. In the same fashion, if you want to do the clustering concepts in the supervised learning, here we are going to use the classification. Okay, based on the classification, that what we are going to do, we are going to separating the data by seeing the features. Okay. Here we can find several different types of classifications that we can find here. We can find support vector machine, we can find neural network, we can find Navy based Bayesian network, logistic regression. These are some of the classification techniques that we can find in the supervised learning. Along that what we are going to do, here we can find binary classification and multi-layer classification, multi-label classification. Here, the name itself indicating binary classification. Binary classification is nothing but, for example, if you take a people, there we can find two genders, male and female. For example, if you have a group of people, means by using binary classification, that what we are going to do, we are going to separate the males in one side and the female people in the other side. This is nothing but a binary classification. For example, multi-layer classification is nothing but we are going to group boys one side, girls one side, and none the third gender that we are going to categorize into the third domain, like that. Okay. Similarly, we can find the multi-label classification. In the multi-label classification, that what we are going to do, we are going to find many labels, and we can find many outputs and many categories. For example, if you take movies, okay, movies, there we can find several different types of parameters in the movies. That means some movies are related to action movies, some movies are related to the thriller movies, suspense movies, like that. We can find some movies are romance movies, okay, like that. For example, if we take two movies, that is nothing but, for example, if you compare the Endgame movie, I think people know about the Endgame movie. It is an Hollywood movie. we are going to compare this end game movie with the our latest Telugu popular movie, that is nothing but Drishyam movie. For example, we are going to comparing these two movies. Means that what we are going to first, we are going to see whether the end game movie in this action is there or not. Similarly, we are going to see Drishyam movie whether the action part is there or not. For example, if the action part is there, means we are going to take that one into parameter one, and if it is not there, means we are going to classify that one into zero. Similarly, we can give the we can separate the things by using parameters like thriller, suspense, like that. We can use several different types of classifications that we are going to use in this. Okay, and in the machine learning, we are going to find several different types of algorithms. Okay? We are going to use neural networks, and we are going to use random forest, and we are going to decision tree, this one, and we are going to use a genetic algorithm, radial basis function algorithm. Like that, we are going to use several different types of algorithms that we are going to use in the machine learning applications. The people are going to concentrating or are going to think majorly Python is one of the powerful tool to do the programming in the machine learning. I think so many of them don't know. Not only a Python is going to use in the machine learning programming. Along this Python, we can also use Java. We can also use C, C++, Shell, R programming. R programming also it is one of the very powerful language. JavaScript, Scala, Shell, Julia. These are the some of the programming languages that we can use to write programs in the machine learning. Now, here in this particular slide, we can find some of the advantages and disadvantages of the machine learning. Okay. The advantages of the machine learning here is nothing but here it is very fast, accurate, and efficient, and it is going to do the automation of most applications and wide range of real life applications we are going to use. And we are going to use enhanced cyber security and spam detection also. No human intervention is needed. For example, if you take some nuclear reactors, there, if you want, the human can't go to that particular thermal plant or some nuclear reactors. There, that what we are going to instead of sending human, that what we are going to send in the AI machines, handling multi-dimensional data, and all these things that what we are going to do with the machine learning. The next one is nothing but here, however, it is having some merits, similarly, it is having some demerits, that is nothing but disadvantages of machine learning. It is very difficult to identify and rectify the errors in the machine learning. Okay, there is a lot of research going on this particular area, and data acquisition also. That means this is also one of the very, very important parameter we have to consider on the data acquisition. Okay, here continuously we are going to getting the data, so that here also there is a lot of scope is there, research scope is there here in this particular data acquisition. Next, interpretation of results require more time and space. That is one of the drawback of the machine learning. Here, these are the some of the what we can call merits and demerits of the what we can call deep learning, machine learning. So that in order to overcome these things, that what we are going to using deep learning. Okay, initially we have AI and ML, then now we are using deep learning. Deep learning here is nothing but, okay, that what the scientists are going to do, they want to excuse, here sorry, here the scientists want to design a machine that it has to mimic like a human brain. That means they want to design a machine, and that machine has to think like a human brain. Okay, that means they are going to designing, that means they are going to creating some architectures. Okay, okay, in order to design the brain architecture, that what they are going to do, they are going to use using multi-level multi-layer neural network concepts that they are going to use. Okay, in deep learning we have three different types of uh, techniques are there. That is nothing but a artificial neural network, and convolution neural network, and RN, recurrent neural network. These are the three powerful neural network concepts that they are going to use to um, they are going to using they are going to use to design these particular deep learning concept. They want to design a machine like human brain means there they are going to using these three different types of um, networks. That is nothing but artificial neural network, convolution neural network, and RNN. Here, if you see the major difference between the deep learning and machine learning, here we can find in this particular slide I mentioned very clearly. Here, in the deep learning, that what will happen, the feature extraction, the classifications are going to done in single stage. But whereas in the machine learning, it is not like that. Okay, there what we are going to do, the feature extraction is going to done by someone, and the classification is going to done in the another way. Okay, but whereas in the deep learning, these two, that means the feature extraction and classification, both are going to happen single stage the deep learning. For example, here we are going to give a input, for example, a car, and then we are going to finding the features. That means we are going to see the features of the car. That means the tires, then engine shape, then what we can call some parameters that we are going to consider. Based on that, we are going to see whether the input is a car or not in a car. Okay. Here in this particular slide, we can see one more image that is nothing but here artificial intelligence. Okay. Inside this artificial intelligence that we can find the machine learning. Inside the machine learning, that is nothing but a deep learning. Okay. That means here the machine learning is a subset of the artificial intelligence, and the deep learning is the subset of the machine learning. By integrating these three concepts, that is nothing but what we can call artificial intelligence, machine learning, and deep learning. These three concepts together is going to called as a data science. That means being in a data science, he should be thorough in these three domains. Okay, that means he is good in the artificial intelligence, and he is good in the what we can call the machine learning, and is good in the deep learning. If he is good in these three domains, then only we are going to say he's a good data scientist. Okay, a data scientist nothing but it is an integration of the artificial intelligence, machine learning, and deep learning. Here you can find the deep learning is a part of broader family of the machine learning method based on the artificial neural network. We are going to use learning can be supervised and semi-supervised or unsupervised. Okay. We discussed just now what is mean by supervised and semi-supervised and unsupervised. Okay. Here we are going to see some of the deep learning algorithms. We are going to see uh, in this particular presentation. I am going to explain 10 different types of deep learning algorithms that I'm going to tell here. The very first one is nothing but a auto encoder. Okay, this auto encoder was first designed in the year 1980 by Jeffrey Hinton. Okay, he is designed this auto encoder. Here, if you see the structure of this auto encoder, here we can find total three components. Okay, the very first one is nothing but a encoder. In the middle one is nothing but a code, and the final stage is nothing but a decoder. Okay, here it is having total three stages. That is nothing but encoder, code, and decoder. Okay, for example, here we are giving some nice input 4, and by applying on this particular image by using auto encoder algorithm, that what we are going to do, we are going to eliminating the noise, and we are going to getting the clear image of that particular 4 that we can find in the output side. Okay, here here we are giving input 4, and it is having some noise, and we are feeding that one to the auto encoder. This auto encoder is having total three components. The very first stage it is having a encoder, and in the middle stage it is having a code. This is the code. Okay, and the next one is nothing but a decoder. Okay, and finally we are going to get the output by eliminating this particular noise. This is the very first auto encoder. In the olden days, or in the early 1980s, they are going to use these auto encoders regularly. Okay. Next one is nothing but a restricted Boltzmann. Here, RBM is nothing but a it is a generative restricted Boltzmann machine. RBM is a neural network. It is a stochastic neural network, and it is having total two layers that you can find. One is a visible unit, and second one is a hidden unit. You see here in this particular image, you can find the very first one is nothing but a visible unit, and second one is nothing but a hidden unit. Here, each and every node in the visible unit is going to connect it to the hidden hidden unit. Okay, That means here node 1 is going to connect to all the nodes in the hidden nodes. Okay, that means here uh, each visible unit connected to all units in the hidden units. Okay, and in between this visible unit and the hidden unit, that what we are going to using here a bias. Okay, here we can find that one is nothing but a activation function. Generally, that's what we are going to do. We are going to use here activation function. Okay, activate the main intention of this activation function is here is nothing but that what we are going to here we are going to reducing the loss. Okay, the main usage of these activation functions, what the activation functions are going to do is, here it is going to reducing the noise. Like that, we can find several different types of activation functions are there nowadays in the market. We can find the what we can call the linear activation function, and we can find the ReLU activation function, and we can find the um, leaky ReLU or eReLU, softmax, and the powerful what we can call the activation function is nothing but a sigmoid function. This is also one of the very powerful activation function that what we are going to use to reduce the noise. Okay, that means here what we are going to do. The last function is nothing but generally we are going to represent last function is equal to half into y minus y dash whole square. Okay, that what we are going to do. We are going to see the last. Okay, for example, if you are getting a loss means, then what we are going to feed forward and feed backward, and then what we are going to do by using this bias function, we are going to reduce the losses. That means we are going to these concepts that we are going to see at the time of optimization. Okay, after this algorithm, how we are going to do that. Like next one is nothing but a DBN. DBN stands for your deep belief network. Okay, here the structure of the deep belief network that you can find here, it is having a multi layers. In the DBN, it is having a multi layers. So if you see here, you can find a input layer, and we can find a hidden layer 1 and hidden layer 2, hidden layer 3, and then output layer. Okay, here we can find what we can call uh, latent variables. That is nothing but here we can find uh, hidden variables. Latent variable is nothing but a hidden variables. These hidden variables that we are going to find in the hidden layers. These are not directly connected to the hidden nodes. These are going to connect it to the hidden layers. Okay, it consists of multiple layers of latent variables. Okay, the hidden variables have binary values called the hidden neurons. Okay. DBN can be viewed as a composition of simple and unsupervised. You can find here DBN can be viewed as a composition of a simple unsupervised network such as a RBMs or auto input. Just now, RBM is nothing but a restricted Boltzmann machine and auto encoder. Okay, these are like some of the some unsupervised network that got researched. Generally, the DBN can be used for image and video recognition and motion capture. Okay, in these applications, generally that what we are going to we are going to use the DBN and nowadays in the medical side also that the people are going to use the deep belief networks uh, to find what we can call either maybe a EEG signal or it may be a ECG signal. That means in order to find the fault or in order to compare the healthy human EEG signal and if you see EEG signal, that what they are going to do, they are going to use this DBN algorithm, and they are going to do some of the what we can call the parameters that they are going to identify and they are going to classify. Okay, and it involves also tracking the data of objects and people in the belief network. Okay, next one here is nothing but a SOM. Here SOM is nothing but self-organizing map. SOM is nothing but a self-organizing map. The SOM was introduced by the T. Kohinen. He is a Finnish professor. Sometimes people are going to call SOM algorithm is nothing but a Kohinen network. The another name of the SOM is nothing but a Kohinen network. It is an unsupervised machine learning technique. Okay, and it is easy to produce a low dimensional. Typically, that means it is a two-dimensional representation. That here in this particular image, here we can see here we have a input. It is having several different types of colors are there. That what we are going to represent that one the two-dimensional map. Okay, here Here we can find two layers, that is nothing but a input layer and completion layer. Again, in the completion layer, we can find three basic operations that we are going to perform, namely completion, cooperation, and updating. Okay. This is about the SOM algorithm. These are the some of the algorithms that we are going to use in the deep learning. Along these, we are going to use one more powerful algorithm that is nothing but a multi-layer perceptron. Okay. Here, this multiplayer perceptron is a class of feed-forward artificial neural network. Okay, it consists of multiple layers of perceptrons, that is nothing but neurons with activation functions. Here, if you see here, here we can find in the hidden layer that we can find here some activation functions. Okay, here we are going to use. Just now I said several different types of activation functions are there. That is depending on the data and our requirement, that we are going to use any one of the activation functions. If you want, for example, if you are taking a two images or two classification, is that is nothing but that there we are going to use the linear activation function generally that we are going to take. Okay, for example, now the powerful activation function is nothing but a sigmoid function also that we can use. Okay, multi-layer perceptron classifies the data sets that are not linearly separatable. Okay, it consists of two layers. One is the input layer and second one is the output layer. In between, we can find the hidden layer. They may have the same number of inputs and the same number of outputs. Okay, here if you see here, we can find here three inputs are there, and here we are going to getting only two outputs. That is nothing but cats and dogs. Okay, here the inputs, for example, two means here we are going to find the outputs also two. Sometimes it may, that means the input and the output both are equal, or sometimes these two are may not. Here next one is next algorithm is nothing but here radian based algorithm, that is nothing but it is a special type of feed forward neural network. That means that what we are going to here we can find the it has a hidden input layer and a hidden layer and output layer. This radial based function network, here we can find uh, the neurons in the hidden layer contains the Gaussian function whose output is the center of the neuron. That means here that what we are going to do in a yellow color dot that we can find here the weights W1, W2, W3, and here we are going to use some of the activation functions. And the next one is this is one of the very powerful algorithm nowadays. It is a very popular one, that is nothing but a GAN algorithm or GAN architecture. Okay, GNE stands for here generative adversarial network. Okay, this is one of the very powerful algorithm. There is a lot of research is going on by using this GN algorithm, the generative adversarial network algorithm. GN are a deep learning based generative model that is used for unsupervised learning. It is basically a system where two competing neural networks compete with each other to create or generate variation in the data. For example, if you see in this architecture, then you can easily understand this one. Okay, Ian Goodfellow is a we can say he is a father of the deep learning. Ian Goodfellow is a father of the deep learning. He invented this GAN architecture or GAN. Here we can find random input vector. Here we can find two blocks, that is nothing but a generator model and a discriminator model. Okay, by using this generator model and a discriminator model, that what we are going to get the output here is nothing but output here is nothing but a binary classification output. That means whether the image is a real image or a fake image. Okay, for example, that what we are going to do, we are going to compare this one to the real example. Okay, for example, the beauty of this GAN here is nothing but here we can generate our for example Hyderabad nowadays from last 2 or 3 days onwards we can see the total Hyderabad is going to covered by fog. Okay, that means here uh, we can get the Hyderabad image by taking the normal image of the Hyderabad, then if it is covered by the fog, means we can generate that fogged Hyderabad image by using this GAN. That's nothing but a generative adversarial neural network. That is the beauty of the GAN. Okay, the GAN architecture consists of two submodels known as the generator model and the discriminator model. By using this discriminator model, that what we are going to do in the discriminator model, we are going to compare real example with the generated example, and here we are going to see whether the generated example and the real example both are equal or not. If the what we can call it, the loss here is equal to 0, means we are going to say that it's nothing but it is a real example. For example, if the loss is more, means here we can assume that there is a fake image. Okay, like that we can assume. So that here we can find some feed-forward networks also. The next one is nothing but a SR GAN. SR GAN is nothing but your super resolution GAN. Okay, here this image is trained in such a way that it can generate a photorealistic high resolution image when given a low resolution image to this particular one. We are going to get high resolution image by using this what we can call the super resolution GAN. Here we can see the very first one is nothing but a bicubic SSR, ESNet, and SR GAN. Okay, if you see the last but one, that is nothing but super resolution GAN. Okay, the image of the super resolution GAN is exactly equivalent to the original image. Okay, that means that what we are going to do here, we are going to generating the high quality images by using this SR GAN. And the next one more very what we can call the popular GAN here is nothing but a cyclic GAN. Okay, the beauty of the cyclic GAN here is nothing but okay. Yeah, this one also uh, proposed in the year 2017 by Goodfoot. He is the father of the deep learning. Okay, we can find his lectures in YouTube. Okay, several lectures that we can find related to the Ian Goodfoot. Okay, here if you see this by seeing these images, that we can easily understand here the beauty of the cyclic GAN. That means that what I am going to do here, see here we can find the background scenery is there. That simply that what I am going to do, I am going to replacing these zebras by R's. Except these zebras and R's, the background images are similar. Similarly, in the summer and winter also, that means that what we can do, we can imagine by sending this summer image peak. Okay, we can imagine how the winter image is going to be look like. Okay, like that we can find here some of the images. Similarly, you can see here single horse and zebra. There, that what we are going to do. Here simply that we are replacing horse by zebra. Like that we can find some of the images that we can find here. Okay. These are the some of the applications of GAN. Okay, by seeing these applications now we can understand the importance of the GAN in nowadays. Okay, we can also generate examples of image data sets, and we can use this one for generative new human process like Photoshop emojis, photographs of editing, face gauging. I think last 1 or 2 years back we can find in Google Play Store one popular app that is nothing but, for example, if you give your image, it is going to convert your image to 10 years back or childhood image, or it is going to generate your image after 60 years or 80 years, like that. All that applications that what we are going to do, we are going to use these GAN applications only. They use it to generate these type of apps. Okay. We can also use this one for photo blending and super resolution images. If you want to get the super resolution image, means we are going to use the SRGAN. Like video prediction, 3D object generation. In these applications, not only this one, we can also find several different types of applications. We can find yeah. The next one is nothing but a recurrent neural network. Generally, we saw till now that are nothing but a image related neural networks that we saw. And now this recurrent neural network, these recurrent neural networks are going to uh, use in the continuous signal. That is nothing but for example, audio or image that audio or video processing. That generally that what we are going to use recurrent neural network. The recurrent neural network is nothing but a time variant. Time variant or time series kind of data that we are going to process by using this RNN or recurrent neural network. The term recurrent neural network is used to refer to the class of networks with infinite impulse responses. But whereas in the convolution neural network, that what we are going to do, we are going to find only finite impulse responses. Okay, that is a major difference between the convolution, or that is nothing but a CNN, and the RNN is nothing but in the CNN we can find only finite impulse responses, but whereas in the RNN we can find the infinite impulse responses that we can find. And here this is the RNNs are commonly used for image capturing time series. That is nothing but a what we can called continuous images or NLP and machine translations that you can find here. Here in the below we can find, for example, if here you can see how to copy SL in Google. For example, if you search like this, how to copy SL in Google, so that what will happen? All the related articles, what we are going to do, we can find in the result page. Okay, this is going to done by using this. Here we can find a database that is nothing but a collection of vast volume of most frequently occurring consecutive words. Okay, the things are that we can find in the database. Okay, whenever we are going to search these keys. Okay, all the related info, all the these keys related information that we can find in the result uh, sheet or in the result page that you can find. This is one of the latest algorithm that we are going to use nowadays popularly. That is nothing but a long short-term memory. The name itself indicating here long short-term memory here is nothing but here we can find some feed forward, so that in order to store the previous results that what we are going to do, we are going to use some of the memory elements. Okay, LSTM is an artificial recurrent neural network architecture used in the field of deep learning. It is also capable of learning and memorizing long-term dependencies. Okay, that means here we are memorizing the long-term. Here is nothing but we are going to use some of the memory elements to store that particular information. LSTM structures are like a chain, but representing module have a different structures. LSTM as a feed feedback connections, that is nothing but a in order to store the previous information that what we have to do here, we have to use a feedback connections. Okay, it can process not only a single data points, okay, but also entire sequence of data that we can. Okay, that means here we can also use a speech or video information. LSTM is also applicable to tasks such as unsegmented and connected handwriting recognition, speech recognition, and anomaly detection in networking traffic or IDs, that is nothing but intrusion detection systems. Some of the applications related to this long short-term memory is nothing but a speech recognition, music competitions, and sign language translations. In these, we are going to use this long short-term memory. The next one is nothing but a convolution neural network. Convolution neural network here is nothing but a here generally in the convolution neural network, that what we are going to do, we are going to take the data image like an take the data like an image. Okay, in deep learning, a convolution neural network is a class of deep neural network most commonly applied to analyzing visual uh, images. Generally, that what we are going to do in the convolution neural network, we are going to take the data like an images. Okay. Here we can find a fully connected CNN network. That means here all the nodes. That means each and every node is connected to all the nodes in the hidden layer. Okay, all the hidden layers are going to each and every hidden layer is going to connect it to all the second stage hidden nodes. Okay. Here, generally, that what we are going to use in the convolution. We are going to use the convolution layer, pooling layer, and filtering. Okay. Again, in the pooling is nothing but here we are going to use sometimes max pooling and minimum pooling concept. That also that we are going to use depending on our data, depending on our application. This CNN can be used in image processing and object detection. Generally, we are going to use the convolution neural network, but whereas in the just now we saw RNN, that recurrence neural network, there we are going to that RNNs are going to use for the um, video or audio processing. Okay, here we can find some of the filters that we are going to use in this convolution neural network. Okay, here for example, the image size here is equal to 6 by 6. For example, here the image size here is equal to 6 by 6. Here is nothing but that what we are going to do. Here we are going to use a 3 by 3 filter. Okay. By using this 3 by 3 filter, that what we are going to do, we are going to resizing this particular image. For example, you see here I'm using a filter that is nothing but 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1 1. That means that what we are going to do, we are going to do the convolve operation between the this filter with the first 8 cells. That means the 3 by 3 matrix. Okay, that is nothing but here we can find 1 into 1 plus 0 into minus 1 plus 0 into minus 1, like that, 0 into minus 1, 1 into 1 plus 0 into minus 1, like that, 0 into minus 1, 0 into minus 1, 1 into 1, like that. The very first step that what we are going to do, we are going to get 3. That is nothing but by doing the this filter one with the 6 by 6 matrix, we are going to take the sub matrix that is nothing but a 3 by 3 matrix. After taking the 3 by 3 matrix with the filter one, after finding the dot product, we are going to get 3. Okay, the result value. Then we are going to stride one. Then we are going to take the next 3 by 3 matrix, and again we are going to do the filtering operation. Then we are going to get -1 like that. And this is about that what we are going to do in the convolution operation. Okay, these are the some of the algorithms that what we are going to do is what we are going to use in the deep learning. The next one here is nothing but a optimizers. Okay, here we are going to use several different types of optimizers in the what we can call deep learning. Okay, that is nothing but a gradient descent or stochastic gradient descent, mini batch gradient descent, and momentum based gradient descent. Network, that is nothing but NAG gradient, NAG and ADA-grad RMS probe ADAM. The ADAM is the latest optimizer. Before going to see these optimizers, first here we have to know what is mean by optimizer and what is the importance of the optimizers. Okay, by using these optimizers, that what we are going to do, we are going to reducing the loss. Okay, by using this optimizer, the main concept of optimizer is to reduce the loss. Okay, that means here we can find a loss function. Loss function here is equal to r into y minus y dash whole square. Okay, here we are going to reducing this one. For example, if the loss function is more, means that what we are going to do, we are going to do the back propagation, and then we are going to change the weight of each and every node. By varying the weight, that what we are going to do, we are going to minimizing the losses. Okay, here in the optimizers, the main concept here is nothing but weight. The finding the weight is one of the very important task. Okay, here we are going to varying the weights of the in to getting the minimum losses. Okay, we are going to use these many different types of optimizers. Generally, that we are going to use the deep learning. Here, the very first one is nothing but a stochastic gradient. Okay. Here, for example, here I have a input. Here we have 3 nodes are there, and these 3 nodes are is nothing but a input nodes, and here we have a one single output. Okay, and here that what I'm going to do, I'm going to connect each and every input node to the hidden layer. Okay, here we can find 2 hidden layers are there. Okay, here we can find 2 hidden layers are there. My input node 1 is connected to the hidden layer, all the nodes. Okay, similarly, input node 2 is going to connect all the nodes in the hidden layer. Similarly, input node 3 is going to connect all the nodes in the hidden layer. Okay, here after that, next what we are going to do, we are going to give this output of the hidden layer to the output node. Okay, hidden layer node 1 output to the output node, and then hidden layer node 2 to the output of the output node. There, what we are going to do, we are going to get the final output. If the final output here is equal to final output is not equal to 0, so that here we can assume there may be a loss in the data. So that in order to reduce these losses, that what we are going to do, we are going to do the back propagation. Okay, that means that what we are going to do, we are going to come back, and then what we are going to do, we are going to change the weights. For example, the first node weights are W1, W11, W12. Second node is nothing but W21, W22. Third node weight is nothing but W31 and W32. Okay, that means that what we are going to do, we are going to changing the weights, and by varying the this weights, that what we are going to do, we are going to reducing the uh, loss. Okay, and here also it is having some of the what we can call the merits and demerits in the gradient descent. Okay, the advantage of this gradient descent is nothing but it is the oldest one, and it is easy to understand, and it is easy to implement. Okay, the major drawback of this gradient descent here is nothing but, for example, if I am taking 10,000 records. Okay, for example, if my data set is having a 10,000 records, means that what I am going to do, I have to train all the 10,000 records at a time. Okay, here what I have to do, I have to train all the 10,000 records at a time. Means it is very tough task to um, take all the 20,000 records. Okay, that means the processing of 20,000 records is very tough task. That means it is going to take a huge amount of memory space. That means it is going to occupying the that means the RAM is going to consume more what we can call space. Okay, this is the major drawback. Okay, in the gradient descent algorithm. So that in order to avoid this drawback, that what we are going to do, we are going to use the stochastic gradient. The stochastic gradient, that what we are going to do, instead of sending all the 10,000 data sets at a time, that what we are going to do, we are going to send one data set at a time. Like that, what we are going to do, we are going to sending 10k times. That means 10k times, that what we are going to do, we are going to process the data. Okay, this is the advantage in the stochastic gradient. Again, here we can find some of the advantages and disadvantages. Okay, the advantages of the stochastic gradient here is nothing but frequent updates of model parameter. That means we can find the updates frequently, and it requires very less memory. That means there, that what we are going to use 10,000 10k data set at a time, means it is going to occupy huge amount of memory space. But here it is not like that. We are going to take one data set at a time, so that it is going to occupy very less memory space, and it allows the use of large data sets, and it has to update only one example at a time. But the drawbacks of the stochastic gradient here is that, but the frequent can also result in noisy gradient, which may causes the error to increase the instead of decreasing it. And here we can find here we are taking 10k times, so that the variation also we can find high variance that we can find, and the frequent updates are computationally expensive. So that again, in order to eliminate the drawbacks in the stochastic gradient, that what we are going to do, we are going to use the mini batch stochastic gradient. Okay, this mini batch stochastic gradient is nothing but it is a combination, or it is a integration of the stochastic gradient and the batch gradient descent. Okay, it is a simple. That means that what we are going to do, instead of in the very first case, that what we done, we taken all the data sets at a time. In the second stage, the stochastic gradient, that what we done, we taken one data set at a time. But in the mini batch, that what we are going to do, we are going to dividing the total data into some batches. Okay, that means by taking the total data into some mini batches, then what we are going to do, we are going to process this data. It is simply splits the training data set into small batches, and then perform the update for each and every data set. Okay, that means for each and every epoch, that what we are going to do, we are going to getting the variation also. That means here we can make that one to the data set into 52 to 56 data sets, like that. That we can convert. Next, the drawback of the mini batch gradient descent, and what we can call advantages of the mini batch gradient descent here is nothing but it leads to more stable convergence and more efficient gradient calculations, and requires less amount of memory compared to the gradient descent. Okay, and the advantages of this one and the disadvantages of mini batch gradient descent here is nothing but the mini batch gradient descent does not guarantee good convergence, and if the learning rate is too small, the convergence rate will be too slow. Okay, if it is too large, the loss function will oscillate or even diverge at the minimum value. So that in order to avoid this one, that what we are going to again we are going to use one more optimizer, that is nothing but a HGD with the momentum, that is nothing but stochastic gradient descent with the momentum. Okay, here the stochastic gradient with the momentum here is nothing but it is a other optimization method that adds the momentum term to um, to regular stochastic gradient descent. Momentum simulates the inertia of an object when it is moving, that is the direction of the previous update is retained and its certain extension during the update, while the current update gradient is used to fine tune the final update direction. In this way, we can increase the stability to a certain extent so that you can learn faster and also have the ability to get rid of local optimization. And the momentum formula for this one is equal to V nu is equal to eta into V volt minus alpha into dou loss by dou volt. That means weight of the volt. Okay. And the advantages of this one SGD with momentum here is equal. Momentum helps to reduce the noise, and exceptional weighted average is used to smoothen the curve. Okay. By using this momentum, that what we are going to smoothen the curve. The major disadvantages of this HGD with momentum here is nothing but extra hyperparameter is added here. Okay, that is nothing but eta into V volt, that parameter that we added here. Okay, and in order to avoid this drawback, that what we are going to use one more powerful algorithm, that is nothing but a adaptive gradient descent. Simply, we are going to call this adaptive gradient descent is nothing but a ADA grad. Okay. In all the above algorithms, we can find the learning rate is remain constant, but in the ADA grad, we can use different learning rates for each and every neuron, for each and every hidden layer based on the different iterations. Okay. New weight is equal to volt weight plus alpha by square root of catching mu plus epsilon into dou loss by dou W volt. That is nothing but this is the ADA grade equation, and it is having some of the advantages compared to the previous optimizers. Okay, this learning rate changes adaptively with the irrespective with the iterations, and it is able to train sparse data as well as. Okay, but the disadvantages in this ADA grade here is nothing but the neural network is deep, the learning rate becomes very smaller number, which will cause dead neuron problem. That means the deep neural network, that what we are going to do, we are going to use the huge number of hidden layers. That means if we take more number of hidden layers, then we are going to get that much accurate output that we are going to get. And the next one is nothing but in order to avoid the drawback, that what we are going to use RMS prop algorithm. That is nothing but root mean square propagation. Okay. RMS is a special version of ADA grad in which the learning rate is an exponential average of the gradient instead of the cumulative sum of uh, squared gradient. RMS prop basically combines momentum with the ADA grad. Okay, the formula for this one here is equal to catchy nu is equal to gamma into catchy volt plus 1 minus um, gamma into dou loss by dou volt whole square. Okay, advantages of RMS probe here is nothing but its learning rate gets adjusted automatically, and it chooses a different learning rate for the each parameter. And the disadvantages for this RMS probe here is nothing but it is a slow learning process. Okay. Next, in order to avoid this drawback, that what we are going to use ADA delta. Okay, ADA delta is an extension of the ADA grad optimizer, and it is also tries to reduce ADA grads aggressive and monotonically reducing the learning rate and remove decaying learning rate problem. In ADA delta, we do not need to set the default learning rate, as we take the ratio of the running average of the previous time steps to the current gradient. Okay. The advantages of this ADA delta here is equal to the main advantage of the ADA delta is that we do not need to set default learning rate. But the drawback in this ADA delta is nothing but computationally it is very expensive. So that what we are going to do, we are going to use the final, that is nothing but the last optimizer, that is nothing but a ADAM optimizer, that is nothing but a adaptive momentum estimation. Okay, it It is the Adam optimizer is one of the most popular and famous gradient descent optimizer algorithm. It is a method that computes adaptive learning rates for each parameter, and it also stores both the decaying average of the past gradients and similar to momentum, and also decaying average of the past squared gradients. Okay, it is similar to the RMS probe and Adadale. Thus, it combines the advantage of both the methods. That means it is going to it is simply we can say like this. It is the integration of RMS probe and Ada delta is nothing but a Adam optimizer. Okay, here we can find the advantages. Here is it is easy to implement and computationally efficient, and it required very little memory. So that nowadays people are going to use the Adam optimizer. This is one of the very powerful optimizer. Okay, this is about optimizers in the deep learning. I think it is useful for few people. That is nothing but both in the algorithms and optimizers. That part nowadays we are using in the deep learning. This is about today's talk. If anybody have any queries, please post your queries in chat box, or you can raise. Yeah.
Hello, sir.
Yeah. Good evening.
Thank you for the wonderful presentation.
Thank
you. Actually, we were discussing about the image processing in deep learning. So
Okay.
what can we do for signal processing? Actually, we were working with EEG signals.
Yeah.
Classification.
For EEG signals, we can find DBN networks are one of the best algorithm that you can use for EEG or ECG signals. Okay, in the image means that is one of the best algorithms that we can use. Deep belief networks. Okay.
Can we run using MATLAB?
Yeah, we can, madam. But it need some powerful tools that it required. Okay. What exactly you need, where you are facing problem. If you post that one to my mail ID, definitely I will answer for the question. Okay, madam.
Okay, thank you.
Can I ask some question, Doctor?
Yeah, sure, definitely.
Yeah. Actually, for the slide number 47, you have used some convolution theorem, something, yes?
Yeah.
To change the matrix, like a 3 by 3 matrix.
Yeah, excuse me. Slide number 40. Yeah, 46 or 47. Okay.
Yeah.
Here we are using some filters, convolution. That's what we are going to do. Here, here we are going to enhancing the image quality by using the filters. That means that what I'm going to here, I'm for example, you see here in the slide number 47. Here we can find very clearly. Here the image size here is equal to 6 by 6. Okay, and here I'm taking the filter size here is equal to 3 by 3 filter. Okay.
Okay.
Here that what I'm going to do, I'm going to bring that operation, dot product with the 3 by 3 matrix of the 6 by 6 image into the filter one. That means if you take here 1 into 1 place 0 into minus 1 place 0 into minus 1. This is the first row. Place second row 0 into minus 1 place 1 into 1 place 0 into minus 1. This is the second row. Place in the third row 0 into the filter third row minus 1 0 into minus 1 plus 1 into 1. Like that we are going to get 1. In the first row we are going to get 1 plus 1 plus 1. Like that we are going to get 3. Similarly, next what I'm going to move this slide by one position towards what we can call right side. The same fashion that what I'm going to do the dot matrix operator, dot product operation. So that what we are going to do, we are going to
okay, it means you are converting this 6 by 6 image into the filters, yes?
Filters.
So here the filters are going to be converted, means 0 is going to be converted to 1 or 1 and minus 1 only. We cannot get any other.
Yes. That is depending on the filters that what we are going to take. We are going to get the.
So we have to take the filters first, then we have to generate this one.
Yes.
Okay. Okay, sir. Okay.
Thank you.
Sir, can I ask one question?
Yeah, sure, madam. Why not?
Yeah. Sir, while using MATLAB for deep learning, is there any special packages required?
In
Like
MATLAB.
classic, yeah, any other special toolboxes or anything is required? Is there anything specially for deep learning is available in MATLAB?
Yeah, your question is any special toolboxes are there in the MATLAB related to the deep learning?
Yes, sir.
Yeah, I think we won't find the latest, we won't find these deep learning toolboxes in the olden versions, but we can find these things in the latest MATLAB software. We can find in the licensed software. There we have to purchase the special packages for this deep learning.
Okay, sir. Thank you.
Speak truly, I also never tried in the MATLAB these deep learning concepts.
Okay, sir.
I will leave. Still,
Thank you, sir.
okay. Thank you so much. Thank you all. Thank you, Sabik sir.
Okay, thank you very much, sir, for your nice presentation. Thank you.
Thank you, sir. If anybody have any queries, please post your queries to my mail ID, or we can. These are my mail IDs that you can post your queries to my mail IDs, or you can also send in WhatsApp also. Thank you all. I'm very thankful to my guide, Dr. Ravi Kumar, and
Good evening,
Atul
sir.
Nagesh, yeah, who is this?
Good evening, sir. I want to share my view. I'm G. Pratibha Reddy, working as a government degree lecturer. It's actually really wonderful session, sir. You have covered almost all the algorithms from machine learning to deep learning, including optimizers in deep learning. Altogether, it is a really excellent session. Thank you.
Thank you so much. Still, if anybody have any doubts, please post.
Yeah. One question is there in the chat box. Shall I read it out?
Yeah, sure, sir.
What are the different concepts of mathematics we are using in AI?
Sir, actually, in AI, we are going to use what we can call the linear algebra, that we are going to use neural network concepts, that we are going to use. Here, we have first what we have to go through first neural networks. Then it is very easy to understand the deep learning concepts. While coming to the practical session.
Okay. Thank you. So hope no more questions. So shall we wind up?
Yeah, sure, sir. Thank you.
So
Thank you
it
for
was
giving this opportunity.
Yeah.
Very
It was an
thankful to
excellent
Dr.
session.
Dr.
Yeah, it was an excellent session. I think audience might have gathered more information from that. Started his talk from basics of AI, then ML as a subset of AI. Several real-time examples were quoted. Highlighted various classifiers that can be chosen. Different algorithms were stated. Explained in detail about deep learning, and highlight is that different deep learning algorithms were explained with example. So overall, the session was very useful and informative, and I believe that all the audience might have gathered many information from that, so that they can use this for their future research purpose. So once again, on behalf of IEEE Malabar Subsection, I would like to thank the speaker, Mr. Vanga Reddy, for sparing 1 hour with us and sharing a lot of informative ideas on deep learning. Thank you, sir.
Thank you, Sabik sir. Actually, you people given only 1 hour time. Actually, my intention is I have to cover all the algorithms from starting algorithms to whatever the present algorithm people are using, and whatever the optimizers are there in the deep learning, to cover all these algorithms. I went a little bit fast.
Okay, that I understood. because,
Actually, it is not that means in the webinar, it is not the right time to explain all the algorithms and all the optimizers in detail. For example, if
yes.
it is an AFDP or like that, there we can go one by one optimizer and one algorithm like that. We can take huge amount of time and we can take the huge amount of examples and there we can run and we can show like that. But
Right.
I think my presentation will give little bit idea what are the algorithms are there, what are the optimizers are there in deep learning. Okay, that is my main intention to.
Okay, that's fine. And I think that participants later will be contacting you through either mail
Sure.
or through contact number.
Sure,
So
sir, definitely.
you can address to that.
Sure, sir. I already given my
Yeah, you have shared your mail ID and as well as your
my
contact number.
presentation.
And
I will share this to you. You can
within
share.
1 hour, it is impossible to cover everything in detail. That's true. Okay.
Thank you all.
So
Thank you so much.
Thank you, sir.
Thank you, Sabit sir.
Thank you.
Have a
Thank you. And the feedback link is shared in the chat box. Participants can fill that feedback link to avail a certificate. Thank you.